Again, everyone. Welcome back. Here we are doing our video installment of Lecture 3's notes. And so we're talking specifically and primarily about elasticity in these notes. And so we begin with this understanding of what is elasticity. And elasticity for us is some sort of measurement. It talks about the responsiveness of the quantity demanded to changes in price. And so we begin by understanding, well, why is this different from slope in some way? And we know that slope measurement is really dependent upon essentially the prices that we have in the unit of measurement. So when we talk about a $1,000 rebate on a car worth $10,000, we see that that's a much more attractive offer than a car that's worth maybe $100,000. So we want to understand a little bit more proportionately how changes are affecting supply and demand. So we say that here the slope is essentially dependent on any unit of measurement. And so how to calculate slope using dollars essentially just says that we are looking at the change in the quantity demanded over the change in price. And this, for a linear demand curve, is invariant throughout prices. So we have constant demand. And so when we say that it is dependent on units, we have an example here where we're talking about cents versus dollars. And if we change just the unit, although prices remain the same, if we change the unit, we see slopes change as well. And so we want a better estimation. And so elasticity for us is this essentially the percentage change in the quantity demanded of a good or service given a percentage change in the price. And so what we do here is we're taking the absolute value, and we do so because we know that demand is downward sloping. So because demand's downward sloping, we already know that there's going to be a negative relationship involved. So we're concerned with the magnitude, not necessarily the direction. So when we, again, talk about elasticity, we're looking at this ratio proportionately. And for us, we're going to look at this in a couple different ways. We're going to eventually learn the calculus, but we also are going to understand a little bit intuitively what this means. And so let's continue here in terms of understanding elasticity. So suppose we have the price elasticity of demand for a product is -2. So we have this initial idea that the price elasticity demand is -2. And so we know from the previous formula that's the percentage change in the quantity demanded over the percentage change in price. Well, we're saying that -2 is equal to some difference, right? And we have that we have essentially a -5 in the denominator over essentially the percentage change in the quantity demanded. So if we rearrange the algebra, we get 10 is equal to the percentage change in the quantity demanded. So we know that with a 5 percentage point drop in this product, the quantity demanded is going to essentially rise by 10%. So we move on. Is there a better way to essentially calculate these methods? And there is, and we're going to use this midpoint formula, what we call it. And essentially what we do is take the average here. We're taking this little denominator, looks at the average change in quantity. And the denominator here looks at this average change in price. So we have these average changes, and why we do this is very specific to the idea of elasticity. So imagine we're changing. If we didn't take these averages, imagine we're essentially changing on this demand curve, and we want to move from maybe point A to point B. And so if we move from point A to point B, we're going to get a different elasticity measurement than if we move from point B to point A. And in order to see that, just look at this simple example of going from 99, or from 100 to 99, and then we essentially have then from 99 to 100. Right, so we have negative 1 over 100, and then here we have positive, essentially, 1 over 99. And if we take the absolute value of these, we can still see that this is not equal to this. Right? We don't have that equality there. So we want a better formula for this, and that's what the midpoint formula does, is that we essentially are going to pick a point C, and this point C on this linear demand is going to be really good for us in order to understand where we're essentially at. And so if we, the next problem that we essentially encounter here is that if we imagine some demand curve that's nonlinear, and we still do this same process, A and B, and we create this midpoint, C, what we're doing here is essentially overestimating or falsely estimating what the elasticity will be. And in order to essentially achieve something a little bit better, we're going to have to continuously make these lines closer and closer together so that we are basically looking at a tangential point. And so this tangential point, we know for a nonlinear curve, is going to be slope. And that's essentially what we're going to work with next here, is essentially the point price elasticity of demand. So with this, we're essentially taking the first derivative of our demand curve with respect to prices, and we're essentially multiplying it then by some price and quantity combination. So we're essentially choosing on this demand curve we're essentially choosing on this demand curve some point P1 and some point Q1. And then we're looking at the slope at that very specific point, right? And then we're multiplying it by this relationship. And so we're going to get a much more robust example, some robust outcome, something that's much easier to handle. Because it'll be able to be working with all different, essentially, all different demand curves here. So we then talk about, well, how do we use this? And so this is the example. So if we start with our formula for the price elasticity of demand, we know that it's the absolute value of the partial derivative here of demand with respect to P. And we know that this is multiplied by P over then Q. So with this example, we start taking that first derivative. So we know that essentially Q prime D, that's the first derivative with respect to price, is just going to be negative 2.25. And so we plug that in here, negative 2.25. And then we're going to plug in essentially for price. And so we know prices are going to be 2. But at a very specific quantity demanded, when quantity demanded at price of 2, we have 50 minus 2.25 times 2. So we get is equal to 50 minus 4.5. So we get 45.5. So we plug that in here. And then we're able to essentially solve this down so that we get essentially 0.099. Now, back in the slides, something that we didn't necessarily account for, but we have to, is taking this absolute value. So we want to do that in our slides here. Okay, so we can calculate elasticity of demand now. What does that do for us, essentially? What kind of information is that going to show us? And so we have this essentially breakpoint, and this breakpoint is going to rest at 1. So when we say that we calculate the elasticity of demand and it's greater than 1 in absolute terms, we say that demand is elastic. And so we have the price change in the quantity demanded is greater than the percentage change in the price for this instance. So if we're thinking about this, and we have our original kind of idea of that elasticity of price is equal to the percentage change in the quantity demanded over the percentage change in price, the only way for this to be greater than 1 is if the percentage change in the quantity demanded is indeed greater than the percentage change in price, right? We know that this through algebra. So this has to be true that demanders are very sensitive to price changes. And then for essentially inelastic demand, when we calculate a price elasticity less than 1, we know then if, again, by our intuitive definition, that this has to be true for inelastic demand, then the only way for that to happen is if the quantity demanded, the percentage change of quantity demanded, is less than the percentage change in price. And I think that's a really, really telling result here, and we want to use this intuition. And then kind of lastly, well, what happens at this break-even point, 1? Well, we say that it's unit elastic. And here, again, in order for this to occur, it must be true that the quantity demanded is equal to the percentage change in price. Okay? So we have these 3 results that are forming here, and we want to kind of use this analysis a little bit better to kind of talk about elasticity. But before we do so, we want to talk a little bit about these anchor points. So a good that's perfectly elastic, or a good that has demand that's perfectly elastic, has essentially a value of infinity. And what we end up having here, if we were to draw something like this, is if we have price as a quantity, this would be perfectly elastic. Whereas our next result, when elasticity is essentially 0, so we're going to change these in the slides again so that we know that we have inequality here, right? When it's equal to infinity or approaching infinity, we could say, and when this is equal to 0. So when these are true, we go back and we can draw this demand curve out, and it looks just like this. It's a vertical line. Okay, so the slope is undefined, but the elasticity in this case is 0. So someone astutely might think, well, if we're dependent on proportionate price changes, does a linear demand curve actually have the same elasticity everywhere? And the answer would be no. We observe that in a demand curve, we have a range of elasticities. At the higher ends of prices, we tend to see that these goods tend to be more elastic, whereas at lower price points, we have inelastic. Right? But we're moving, if we move down in price or up in quantity, we're moving to this unit elastic area. And that's going to be important for us as we kind of move into understanding the relationship between total revenue and elasticity. But before we get there, we want to describe, well, how do we change elasticity, or how do we better understand kind of what elasticity is doing for us? And so we say that there's some determinants here of elasticity. And one of the determinants of elasticity, and I think one of the most important ones, is essentially this substitutability that occurs. And so this substitutability tells us that as more substitutes become available, demand becomes more elastic. So the idea is, with consumers having more alternatives and options, they're able to be more sensitive to changes in prices. And so we also like to think of proportion of income as being and playing an important role here in determining elasticity. And so for us, the proportion of income tells us that as it rises and the proportion of income increases to buy a good, that demand becomes much more elastic. Whereas when the proportion of income falls, that demand tends to be much more inelastic. So when we think about that with the demand curve, and we have low prices down in this way, we think that, well, at low prices, these are low proportion of incomes, generally these goods tend to be more inelastic, and that makes sense to us. The next kind of driver here of elasticity is luxuries versus necessities. So since luxuries are goods that consumers can go without to some degree, they're much more sensitive to price changes. Whereas with necessities, these are goods that you must consume. Think about baby formula. It's a necessity, and there's almost no alternatives. So with that, we come very high inelastic goods. And then lastly, the idea is time. Time, again, allows us to find these ideas of substitutable goods. So it takes time to essentially alter any amount being purchased so that when you have more time available, you essentially have more elastic demand. And I think a good example of this is, imagine a person doing their Christmas shopping on Christmas Eve. They must have a very inelastic demand because they have no time to look around and find any alternatives. So how do we use these relationships? And so in class, we kind of divided this out. And I want to make sure that we're clear here in kind of creating this connection. And so when we're looking at essentially the connection between total revenue and elasticity, we might want to start with this total revenue function. So total revenue looks something like this. And it has a maximum point. And we can find out what that maximum point is. So this is total revenue max. And so we can find this point by essentially looking at the marginal changes here. So the slope of this total revenue function is marginal revenue. So all we need to do is take the first derivative in this instance. And so let's go to kind of the formula here and how we're kind of solving this out. So let's just start with this idea that we have total revenue is equal to price times quantity. Now what we want to do is we have quantity as being the driver of total revenue. So we want to substitute out for price in somehow. And so using kind of our inverse demand function here, we're going to say that total revenue is equal to this value A naught minus A1Q times Q. Right? And this is a generalized form. And so if I multiply this out, we have A naught Q minus A1Q squared. And so if I take the derivative of total revenue with respect to quantity now, it's going to be equal to marginal revenue. That's going to equal A naught minus 2A1Q. Now if I want to find this maximum point, I must set this marginal revenue equal to 0. And so I do that here and then solve for essentially Q. And so if I do that, I get 2A1Q is equal to A naught, so that Q is equal to A naught over 2A1. And essentially this will give us this maximizing quantity here, right? So this is equal to A naught over 2A1. So we have this relationship. So how do we kind of set this relationship up with our elasticity? So when we go back here, we know that essentially what's going to happen is at this maximum total revenue, we have essentially this point corresponds to unit elasticity. And that's important, this maximum, which means that anything other than unit elasticity is going to give us lower total revenue. So if we have quantity rising on this side, quantities rising, essentially that tells us then we're at higher prices. And so this side of total revenue would essentially be more elastic. Whereas this side of the total revenue curve corresponds to the more inelastic component. So as quantity rises, which means prices are falling, we essentially are on the elastic portion of the demand curve. And so as prices are falling, we would essentially be increasing our total revenue, right? We're moving towards this unit elastic point. And that's exactly what we see here. So in the elastic portion, as prices are going down, total revenue is going up, right? And so if we start maybe on this side, if we start on this side and quantity is going this way, which means that prices have to be going this way, going up. If that's the case, and we have an inelastic, we're starting inelastic and prices are rising, it must mean that total revenue is also rising, right? And I think this is an important relationship to develop. So again, this maximum point right here, this maximum point is going to correspond with this point up here, where we've maximized total revenue. That's the greatest total revenue that we can find. Anything else is going to be less than our max. And so we want to be able to get to that point or understand where that is. So consider essentially we did this little bit of problem in class, but I think this illustrates exactly what we're expecting here. And that is, consider this demand equation, and we have a few different price points. Can we conclude anything about total revenue? So let's start with the demand curve, knowing that its Q is equal to 50 minus 2.5p. So let's start with our elasticity formulation. So we have dq dp times p over q, so that we have essentially negative 2.5 times p over 50 minus 2.5p. Right? So this is our elasticity of price, and it's going to depend on the prices that we choose here. So let's do a price of essentially, let's do a price of 10. So if we have a price of 10, then our formula kind of works out to be something like this. 50 minus 2.5 times 10. Right, so we have negative 2.5 times 10 over 25. So we should get something like this. Right, if we're taking the absolute value, 1. So right away we know that this should have the highest revenue. Right, this at price P is equal to 10. Total revenue is maxed. So now let's observe what's going on here by looking at a different price. So let's look at a price that might be a little bit lower. So again, we're going to start with negative 2.5 times maybe, let's do 5 over 50 minus 2.5 times 5. So that we have elasticity of price being negative 2.5 times 5 over 50 minus 12.5. And we get here just about 1/3. So what does this tell us? It tells us now that this is less than 1, so we have inelastic demand. And so we can already understand what should happen here. Total revenue should be less than what we found before. So at a price P, if total revenue is equal to price times quantity, so when price was 10, quantity ended up being 25. And total revenue when price was 5, quantity ended up being 37.5. So we have 250 here. And then we have a value essentially less than 250 here with 37.5 times 5, where we have 187.5. So we knew that total revenue would have to go down because of this. Okay, and I think these are important examples. I think as you go through this, you should know how to work through these ideas. And so we continue to go through some of the solutions here. So what are some of the other measurements of elasticity that we can perform? And so one of them is essentially income elasticity. And similar to point price elasticity, we're going to start, but now we're going to look at income. So now we're going to do not the absolute value, but we're just going to look at the partial derivative with respect to I times I over Q. And that's it. So whatever we take the partial with here, so we want to put that here and here. Okay, so this is all income. So this is the income elasticity. Now we're measuring something else here. So what we're measuring is how does income change? So the intuition here is what is the percentage change in the quantity demanded given a percentage change in income? That's the intuition. And so now we're looking at direction. Direction matters. So when this income elasticity is greater than 0, we have essentially a normal good, which means that what happens is income rises, so does the percentage change in quantity demanded. Right? And that fits our definition of what a normal good is. We just have now a more intricate relationship between necessities and luxuries. So if we find that this elasticity is between 0 and 1, we know that it's a necessity. And if we find this elasticity is equal to or greater than 1, it becomes a luxury. Otherwise, anything else we'll find to be negative. And in that instance, we have an inferior good. And so how can we use income elasticity a little bit more? And we went through this in class, but we want to make sure that we are comfortable with understanding the intuition that comes out of the budget constraint with income elasticity. Now, you won't be required in any way to resolve this or find the solution, but I think it's important to know how we get to this conclusion. So we're saying here that our demand curve is now a function of prices of the other good, right? If this is demand for good 1, it's a function of P2. It's also a function of income. And demand for good 2 is a function of our initial prices for P1, again in our income. Okay, so we have our income here, and then we have our budget constraint, which is the combination of the cost of purchasing goods 1 and the cost of purchasing goods 2. Now, if that's the case, why not just start by taking the partial derivative with respect to m? So we know that essentially there's a link here, that this Q is something like this. Right? So if we want to rewrite this to make sure that we're doing it in a much more formal way, we can say that m is equal to P1 times Q1, P1, P2, and m, plus P2 times Q2, which is P1, P2, and m. And now we can see that the partial derivative will be affecting Q. So we take the partial with respect to m, so that we get P1 dQ1 dm plus P2 dQ2 dm. Right, this left side goes to 1. So we have this relationship forming now. And this equality is going to have to hold for us the entire time. Now here comes a math trick. The math trick is that we can essentially multiply and divide by the same value. And when we do that, nothing changes. So the math trick is going to be this. We have 1 is equal to P times Q1 divided by Q1 times M over M. Again, nothing changes. Times dQ1 dm plus P2 Q2 over Q2 times M over M dQ2 dm. Nothing changes. But let's rearrange this now and maintaining this equality. We have P1 times dQ1 dm m over Q1, Q1 over m, right? Just rearranged, plus P2 dQ2 dm m Q2, Q2, M. Now we could cancel these out and we're back to what we originally had, but let's not. Let's notice that essentially we can work with this. This is our income elasticity. So if that's true, let's write that in there. So we have P1 times elasticity of income with respect to good 1 times Q1 over M plus P2 times income elasticity with respect to good 2 times Q2 over M. Now we're left over in this equation with P1 times Q1 times N. And from our budget constraint, we know that P1 times Q1 is essentially the cost of consuming good 1. And now when we divide it by M, we get that this relationship, P1 times Q1 over M, is equal to the proportion of income spent on good 1. And let's say that's omega. Omega is equal to P1 times Q1 divided by M, so that we get 1 is equal to omega 1, elasticity of income 1, plus omega 2, income elasticity 2. Good. So now this is what we want to use, this last little bit, because it's going to tell us something really important here. If we're talking about goods like necessities and luxuries, then what ends up happening with this weighted, with kind of this weighted sum of income elasticities, it tells us that inferior goods must be met with equal proportion of normal goods. Because an inferior good, if this, we're assuming this to be positive, and if this is negative, and this is positive, then what has to happen here is that we need an equal proportion of a positive good. That's happening here. So we need inferior goods to be consumed proportionately with normal goods. So then we ask, well, can we just have luxury goods? Well, we can't just consume luxury goods, because if we need this equality to hold, and we do, and elasticities for luxury goods are far greater than 1, then we can't consume 2 luxury goods, because a positive number and a positive number greater than 1 added to a positive number and another positive number greater than 1 is all going to be greater than 1, and that can't be true. So we need one of these to be less than 1 but greater than 0. So that means we must consume necessities along with luxuries. Okay, so we ran through this example in class, but let's run through it one more time in how to use these understanding. So we already know how to classify the elasticity of income for good 1. Since it's equal to 0.5, we know that it's a normal good and necessity. Whereas the elasticity demand for good 2 is essentially a normal good, but it's also a luxury. So then how do we go about finding out what this classification is for good 3? Well, let's use our formula. So we have 1 is equal to omega 1, elasticity of income 1, plus omega 2 with income elasticity 2, plus omega 3, income elasticity 3. Now don't worry that the weights don't add up to 1. We're not concerned with that right here. This is purely for example purposes. So let's start plugging in what we know. We know we have 0.80 times the elasticity for good 1, 0.5 plus 0.2 times 1.5 plus 0.2, and we don't know what this last income elasticity is. But we can start going through and essentially solving this to get to the idea that this elasticity, now it's just algebra, we find that this elasticity is 1.5. So we know now that this good is normal and essentially a luxury good. So we find that we're able to consume 2 luxury goods and 1 necessity with this budget. And so the last bit that we talked about here in terms of elasticity is this cross-price elasticity. And so the intuition behind this cross-price is we're looking at the percentage change in the quantity demanded of good X over the percentage change in price of good Y. And so our point price elasticity, again, remember we need to get rid of that, but our point price elasticity then essentially tells us this is our first derivative with our demand curve respect to the price of Y times the price of Y over essentially Q dx, right? And again, this Y, Y, and Y all show up. So make sure that if you forget the specific formula, you're using that general point price elasticity method, okay? So what comes out of this? Well, anytime that the elasticity is greater than 0, we essentially have a positive relationship, and these are then substitutes, which means as the price of Coca-Cola rises, the percentage change in the quantity demanded of Pepsi should also rise. And then if we have less than 0, we have complements. And so these were substitutes. So this says that as the price of Doritos increases, the percentage change in quantity of Pepsi should fall, right? And these two goods are consumed together, or chips and salsa, hot dogs, hot dog buns, right? These are the complementary goods that we would notice in this relationship. And that's about it here for this installment of our video podcast. We will continue here with our next chapter on production.